Okay, so example one, there's part A, B, C, and D. All of it's just factoring. A and B pretty much work similarly to each other. C and D kind of work similar to each other. The difference in the problems, let me just point that out first, is problem A and B, the lead term, x squared, there's no coefficient other than just 1. For C and D, it's 2x squared and 3x squared. There's not a coefficient of 1 in front of the x squared term. That makes the factoring chore different for both of those problems. So the top two will factor the same way, same technique. The bottom two will factor the same technique. The bottom two are a little bit more challenging to do. But they're not impossible to do, they're just more challenging. For your skills for Algebra 2 students, you would have done this factoring up here in Algebra 1. You may have gotten to this factoring in Algebra 1, maybe not. We would have seen a little factoring geometry, mostly would have been these types of geometry. So again, the bottom two might be new, maybe not, I don't know, we'll see when we get there. So, here we go. Okay, when you're trying to factor a quadratic trinomial, the first goal is to have proper structure. So you want to have something x squared, something x, and a constant. That's the order you want it to be in every single time. Every problem you have here is going to be in that order. So you're ready to go. I don't know if they're that way in your homework. So if they weren't, just rearrange it so x squared's in front, x is in the middle, and constant in the back. Oh, why this isn't writing here, I'll try again. So what we're looking for specifically comes from specifically two places here. First place is the constant. Put a little highlight here. We're looking for two numbers, two integers actually, that multiply to make the constant. So in general, any kind of algebraic statement they give you, if there's a number with no letter attached to it, that's called a constant. So in this case, positive 12 is the constant. Over here, negative 18 is the constant. Down here, negative 3 is the constant. Down here, positive 4 is the constant. So for these top two, any two integers that multiply to make the constant would be things we want to have on our list. Okay? And this could be either a written down list or a mental list. But we're trying to create two numbers that make 12. 1 times 12, 2 times 6, 3 times 4, right? So we're just trying to find two integers, non-fractions, that multiply to make that. These same two numbers that we find that multiply to make the constant, we're going to try and find that they also add to make the coefficient of x. So I'm going to say they add to make the linear coefficient. I'm opting to speak mathematically to you guys, so the correct terminology here to represent this number in front of the letter x to the first power is called the linear coefficient. Okay. Linear equations have x to the first and y to the first. So x to the first is the linear term. 7 is the linear coefficient. That's the number in front of the linear term. Right? So if I make a complete list here, so if I do this right here, every way I can think of to multiply to make 12. There's 1 times 12, there's 2 times 6, there's 3 times 4, there's negative 1 times negative 12, there's negative 2 times negative 6, there's negative 3 times negative 4.
What if it is a negative?
No, I'm just throwing them all out there. All right? You have to find the pair. If you can find it without writing them all down, that's fine. Okay, that's what you have to do, is find the pair. I could have found the pair without writing down anything. And eventually, I hope that's where you get to with these problems, that you can find the pair without having to write anything down. All right, but can everybody agree that this entire list, 1 times 12 is positive 12, 2 times 6 is positive 12, 3 times 4 is positive 12, negative 1 times negative 12 is positive 12, negative 2 times negative 6 is positive 12, negative 3 times negative 4 is positive 12. If we add all of them up, so 1 times 12 makes 12, 1 plus 12 equals 13. 2 plus 6 makes 8. 3 plus 4 makes 7. Negative 1 minus negative, or plus negative 12 is negative 13. Negative 2 plus negative 6 is negative 8. Negative 3 plus negative 4 is negative 7, right? These right here represent what the middle term coefficient could be, what linear coefficient could be. The one we want, though, is this one, right?
Yep.
So 3 times 4 makes the positive 12 we're looking for. 3 plus 4 makes the positive 7 we're looking for. So 3 and 4 is the correct breakdown of the positive 12 and the positive 7. So the factored form of part A is going to be x plus 3 times x plus 4. The structure is always going to be a binomial structure being multiplied by another binomial structure. The letters in the binomial structures will match whatever this letter is. So this is an x, so this is an x, and this is an x. If this said p squared plus 7p plus 12, I'd write p plus 3p plus 4. So whatever letter they're using, that's what you're going to put in there. All right? So that's how you factor just a general one or generic one, right? Or just x squared, the simple ones. So if I do the same technique here, this time I'm looking for factors of negative 18. What's true of factors that multiply to make a negative 18, the signs of those two numbers? If I'm multiplying, I get a negative result.
Negative.
One negative, one positive, right? So when I make my whole list here of multiplication, so what I usually do is I make a chart. So I want factors of negative 18. If I do negative 1 times 18, and negative 2 times 9, and negative 3 times 6, that's it, right? That's the only way to put the negative first. And then if I go positive 1 times negative 18, and positive 2 times negative 9, and positive 3 times negative 6. That's my entire list. All you have to do to make the entire list is try 1 times something, 2 times something, and so on until you've gotten repetition. So 1 does it, 2 does it, 3 does it, 4 times no integer, right? It'd be 4 times like 4.5, 5 times 3.6. So those aren't integers. 6 times 3, we've already got 3 times 6, so that's the whole list. So again, if you try 1 times something, 2 times something, until you get something you've already hit, that's the whole list. You haven't forgotten any. Now when I write the whole list out, I want the sum to be a positive 3 this time. Again, positive 3, because that's what's written right there, positive 3, sign matters. Negative 1 plus 18, so this entire list multiplies. We've already made that happen. Now we're seeing if this happens. Negative 1 plus 18 is 17. Notice I subtracted because the signs are different. So over here the signs are the same. I added everything. Over here the signs are different. I'm going to subtract everything. 18 is bigger, so it's positive. Negative 2 plus 9, I'm going to get positive 7. Negative 3 plus 6, positive 3. Once you get the pair, see that's the right sum, right? We already know it multiplies to make negative 18 is the right sum. Once you get the right pair, don't feel like you have to complete the list. You can if you want to, but I found what I'm looking for. So again, the letter I'm working with here is x. I'm going to put x minus 3 and x plus 6. The order of those two terms doesn't matter. So if I'd written it like this, x plus 6 times x minus 3, that's also right. Do put the x's in front, the numbers in the back, but whichever factor is which, it doesn't matter what order you put them in. So this is the right answer, or this is the right answer. Either one's fine. They're both equally as good. One's not any better than the other because you wrote it a certain way. As long as you get your letter paired with the two numbers that do the trick. All right, any concerns on those? Because again, those are, well, for lack of a better term, those are the easy ones. These bottom two are harder. Okay. A lot of the same stuff happening, but then there's a certain point where they just go on their own very little way. So the answer is just this. Look, for this first one, this is the answer. And for this, either one of these is the answer. Yeah. So right now, we're just going to be able to factor once. Eventually, we might be able to factor multiple times. Sometimes these factor again, but we're not going to deal with those today. All right, so let's move on to the other section here, these two examples. All right, there's a similarity in what you're looking at. You're still looking at the constant of each of these. You're still looking at the coefficient of x, the linear coefficient. But there's this extra number here, this 2 and this 3 hanging out, that factor into what we're trying to do. Okay, we're going to make a similar chart, but instead of finding numbers that multiply to make the constant, we're looking for numbers that multiply to make two integers multiply to make, see if you buy this, AC. We've already looked at quadratic structures in this class this year, And the basic quadratic structure is y equals ax squared plus bx plus c, right? A is the coefficient of x squared and c is the constant, right? So if I multiply the coefficient of x squared, 2, times the constant, -3, in this case I want numbers that multiply to make -6.
Oh.
Okay. Because again, I multiplied the a value 2 times the c value -3. So I want factors of -6, and I want the sum of those factors to be the same as what it would be anyway, -5. All right. So again, the only difference in the chart is right here, and I got that by multiplying the a value times the c value. Signs do matter. Positive times negative makes a negative. If I make my list, notice I'm going to go 1 by -6, right? 1 times -6 makes -6, and that makes -5. Right off the bat, I find the right pair. That happens sometimes. So, once you see you have the right pair of numbers, here's where it starts getting different. Okay, what I'm going to do with these two numbers, these are my two numbers, is I'm going to transform this term into two different terms with those as my coefficients. Here's what it's going to look like. I'm going to write 2x squared, and then I'm going to write minus 6x plus 1x, and then I'm going to write -3. So if you pay close attention, what I did there, I changed this one thing, -5x, into these two things. And again, those two things based on these two numbers here. -6x and +1x. Notice the order that I chose to put them in. I put the -6x first, the 1x second. It doesn't matter what order you put them in, but if I'm counting terms, this is term 1, this is term 2, this is term 3, and this is term 4. If you can possibly make term 3 positive, it's easier. We won't be able to do that in that one over there, so you see how to handle it when that happens. But if you want it to be the easiest problem it can possibly be, term 1, 2, 3, this term positive. So if one of these is positive, put that in that slot. All right? So that's how the chart works here to break it down partially. Now to factor it the rest of the way, it goes like this. We're going to do what's called factor by grouping. I've created a 4-term polynomial. I'm going to group the first two objects together. I'm going to group the second two objects together. And notice there's a plus sign in between the groups. That's what we want to have between the groups. Plus signs between the groups. So, what I'm looking for in each group is a common factor, something evenly divides both number and or letter of each term. So in the red group here, can everybody see 2 divides both numbers? And both have x to the first or x to the second, so x to the first is common. So I can take 2x out. If I divide by 2x, 2x squared divided by 2x is 1x, -6x divided by 2x is -3. So again, I just see what's common, divide by it. So 2 divided by 2 is 1, x squared divided by x is x. 6 divided by 2 is 3, x divided by x cancels, minus because it's minus. In the second group, there's nothing common. 1x and 3, right? No common factor except for the number 1. I'm going to recommend you write that common factor 1 down though. 1 parentheses. 1x divided by 1 is x, and 3 divided by 1 is 3. When factor by grouping is successful, this binomial should be the exact same as that binomial. That binomial is one of your two factors. You write it down one time. And then the greatest common factors, including the sign that happened right here, makes the other binomial. So 2x plus 1 is the other. And there's your factored form. So just summary before we go to that one, which works the same way. Multiply these to get that, write that down, find your magic pair of numbers that make both things happen, just like we did up on the top one. Instead of just saying x plus 1, x minus 6, we break down the middle term into those two objects with x, common factor, binomial, common factor out, the common factors are in the other parentheses. That's how to factor a lead coefficient, not 1 in a quadratic. So let's go through this process with this one here and see if we can work it out. So, would everybody agree up here? My marker doesn't want to work. Wait patiently for this to respond. I'm going to know how to cut a video so that we can take out stuff like this. I mean, I can hit stop right now and then start recording again, and I have to splice them together. 3x squared minus 8x plus 4. Let's try just opening a new one. 3x squared minus 8x plus 4. All right. So, I want to have factors of what? What do I multiply? 4 times 3. So 4 times 3 makes 12, right? Yes. Factors of 12. I want the sum of those factors to be what? Negative 8. Perfect. So again, to get this number here, we simply multiply A times C. Signs matter. Positive 3 times positive 4 is positive 12. And what goes there is always whatever B is, negative 8. Okay? If I'm going to get a negative sum and a positive product, I need both signs to be negative, right? So would everybody agree that negative 2 times negative 6 does the trick? So again, hopefully that's where you're going to be when you get these to doing these. You're not going to make the whole list of numbers every time. You're going to find the right pair right off the bat, and then you're ready to go. If you can't find it right off the bat, try 1 times 12, 2 times 6, 3 times 4. Start listing every way to do it, and then you'll find it. Negative 2 plus negative 6 is negative 8, and there's our correct pair of numbers. What we do with that pair of numbers is we transform this one term into negative 2x minus 6x. So 3x squared minus 2x minus 6x plus 4. Or 3x squared minus 6x minus 2x plus 4. Doesn't matter, one or the other, doesn't matter about order. Okay? Specifically in this case, since term 1, term 2, term 3, term 4, right? Term 3, this term is negative no matter how I do it, right? So I don't have that nice little positive that I can play with that works. Right? When this happens, when the third term is negative, I recommend for your factor by grouping that you take it down a step. Don't just put parentheses around this up here. So I'm going to put my group here, so 3x squared minus 2x. I'm going to put minus parentheses, and I'm going to write 6x minus 4. And I just wrote down what you're supposed to do. Let me explain why I did it. If I can get a highlighter, that'd be great. Here we go. So that's minus, that's plus, right? Okay. It's very important each time you do another step in these problems that you maintain the same value of your expression as you go through it. Right? So this right here simplifies to this up here, which simplifies to this up here. 3x squared, negative 2x minus 6x is negative 8x plus 4. They're the same thing, right? I just broke it apart. Here, if I distribute minus, it's going to be minus 6x, and it's going to be minus minus 4, which makes plus 4, right? So when there's a minus in that third slot, you're going to get a minus between the parentheses. It causes a sign change to occur that you have no control over. It has to be written in there. You need the value to stay the same. Positive 3x squared, negative 2x, minus 6x, minus minus, so plus 4. That will happen every time there's a minus in the middle. There's no way to avoid it. Just remember you're supposed to do it.
How does it just move to, like, how does it,
How does it pick just that one, not the other? There's officially a plus sign in front of this one, which means that the signs are what they should be. Positive, negative. They're already what they're supposed to be. But this has a minus in front, so minus 6x and minus minus makes plus 4. So
why do you change the plus 4 to negative 4 down there?
because if I put this minus here and I go through the parentheses, minus minus makes positive. And I need the value of this to be the same. If let's pick an x.
Oh.
Let's just pick an x. Suppose I picked x equals 2. 3 times 4 is 12. Minus 2 times 2 is minus 4 is 8. Minus 6 times 2, 12 is minus 4. Plus 4 is 0, right? If I put 2 in here and don't change the sign, if I keep it plus. 3 times 4 is 12. 2 times 2 is 4. That makes 8. This makes 12 plus 4 is 16. 8 minus 16 is negative 8. Wrong sign. Wrong number, right? So that sign change, making it minus 4, 12 minus 4 is 8, 12 minus 4 is 8, 8 minus 8 is 0, right? So again, the structure changed, minus minus makes plus, so I had to put that sign change in there to allow for that. And again, that's the brain bending stuff that happens when you get a minus in that third sign. So when you can avoid it, it's better. When you can't, just know that sign's going to change. All right, now looking at the two groups. We'll do this group in red and this other group in green. First group, common factor of 3x squared and 2x is going to be x, nothing else, right? So if I take x out, the first term has 3x left over, the second term has minus 2 left over.
Wait, so how do you do that part?
So I'm see what's in common. So nothing divides 2 and 3 evenly, right? But letter-wise, they both have x. So x is common. What's going to be common is the lowest power. So the first power. So you take out what's common, the first power, and you divide by it, so each power drops by 1. So x squared becomes x the first, x first just goes away. Second group. There's a minus sign, so I write the minus sign down because that's just what's there. Second group, common factor is 2, right?
Yeah.
So I put 2 down, and I got 3x minus 2 left over. What I'm expecting to happen if it does correct, if it works correctly, is that this should match this, which they do, so that's one factor. And this go together in the other factor. So 3x minus 2 times x minus 2 is the equal.